Hey guys, what's up? So welcome to another video of CHE 101, and today we will be talking about writing elementary rate laws. So just a quick refresher, if we have a reaction A plus B producing C, then the elementary rate law can be written as, let's say, the rate of disappearance of A is equal to K, the rate constant, times the concentrations of the reactant. So that will be A and B. So take note, we also need to consider here the stoichiometric coefficients. Okay, so here I summarize 3 steps in writing rate laws. So first, of course, you need to be aware of which species you want to write the rate of. Then, of course, you need to identify all of the reactants and coefficients of the reactions that contain that particular species. And of course, you write the elementary rate laws. And then take note, when the species is a product, the rate law is positive, and if it's a reactant, it's negative. And then finally, simply combine all of the rate laws. Okay, so it's better to explain this through examples. So here we have, let's have this first example. So let's say we want to write the rate of A. So that would be R sub A. So A only appears in this single reaction. So we write the elementary rate law. So that will be K A squared concentration of B cubed. Okay. Then since A participates as a reactant, then the sign should be negative. And actually, we're now done with the rate law. But then, if we want to write the rate of disappearance, so a positive R indicates the rate of appearance. So if we want to write the rate of disappearance, we simply negate everything. Okay, so the rate of disappearance becomes this one, this expression. Okay. Then if you want to determine the rate of B and C, we should always remember that the rate law is also governed by the stoichiometric coefficients. So that will be the rate of disappearance of A over 2 is equal to the rate of disappearance of B over 3, which is also equal to the rate of appearance or production of C over 2. So if you want to write B, so that will be R sub B equals 3 halves, or negative R sub equals 3 halves of negative R sub A, which is 3 halves K A squared B cubed. Then if you want to write the appearance of C, that will be negative R sub A. So that will be K A squared B cubed. Okay. Now for convenience, for the rest of the examples, we will be using whole number coefficients. So we simply do that by multiplying the by simply adding, or multiplying the coefficient of that particular species to the rate law. So for A, this simply becomes 2k A squared B cubed. For B, this becomes 3k A squared B cubed. Then for C, this still becomes 2k A squared B cubed. So this will be the convention that we will use for the rest of the examples. Okay, so moving on to the second example, we have this series reaction. So let's identify first for A. So A appears in this reaction, A producing B. So we write the elementary rate law. So that will simply be K1, concentration of A. But since A is a reactant, the sign should be negative. Okay. For B, B appears in two reactions, A producing B and B producing 2C. In the first reaction, B acts as a product. So we write the rate law. That will be K1, concentration of A. But since it's a product, the sign remains the same, positive. Now, in this reaction, B now acts as a reactant. So we write the rate law K sub 2 B. But Since it's a reactant, you write it as negative. Finally, for C, it appears only in the second reaction. So we write it as K sub 2, concentration of B. And since C is a product, we write it as positive. And of course, don't forget the coefficient of C. So the rate law will be 2 K sub 2 concentration of B. So I hope you're getting familiarized on how we write the rate laws. Okay. For the next examples, we'll only write the rate laws for one species. So the other rate laws are given at the right. So it's up to you to check on them, both on the expression and the coefficients. So let's begin with the third example. So R sub A, okay. So A appears in both reactions. So let's start with this one. So A appears here as a reactant. So we write first the rate law. That will be K A cube B. Since it's a reactant, this should be negative, and then copy the coefficient. Okay. Then for the second reaction, A is now a product. So the sign will now be positive. Then write the elementary rate law. So that will be K2 D squared E. Then don't forget the coefficient. So that will be 3. And we now have the rate law for A in this reaction. For the fourth one, we have here a reversible reaction. So we write the rate law for A. Okay. We first identify the reaction. So this may seem a single reaction, but A appears in two reactions. That will be the forward reaction and the reverse reaction. So in the forward reaction, A acts as a product. So we write the elementary rate law. So that will be K sub 1 B. Since it's a product, the sign is positive, then don't forget the coefficient of A. Then in the reverse reaction, A now acts as a product. So that will be negative. Sorry, A acts as a reactant. So that will be negative. Okay. So we write the rate law, K sub 2 A squared. Then, of course, don't forget the coefficient. And now we're done with the rate of A. Okay. We move to the last example here. So it's a combination of series, parallel, and reversible reactions. Now we concern ourselves with writing the rate law for B, right? So R sub B. So B appears in 1, 2, 3, 4, 5 reactions. We begin with the forward reaction here. So B acts as a product. So the sign should be positive. Then we write the rate law, K sub 1 A. Then don't forget the coefficient, 2. Then we move to the reverse reaction, which is simply B acting now as the reactant. So the rate law will now be written as negative. Then the elementary rate law, K sub 2 B squared. Then the coefficient, 2. In this reaction, in the forward reaction here, B acts as a reactant again. So that will be negative. Then K sub 3 B squared. Then the coefficient. Then in the reverse reaction, B acts as a product. So that will be plus 2, the coefficient, then K sub 4, concentration of C, the rate law. Then finally, in this reaction, B is a reactant. So that will be negative. And then K sub 7, B, then C cube. Then here, since the coefficient of B is 1, we don't, the coefficient here is 1, so we don't really write anything else. And there we have the rate law for B in this reaction. So that's it for the examples. And here, I made something challenging. So it's a made-up reaction with a lot of pathways. And to make things extra challenging, I would want you to write the rate laws as rate of disappearances. So that will simply be negative R sub A, negative R sub B, R sub C and R sub D. So it's up to you to check if the answers are correct or if there's something wrong. All right, so that's it for this video, and we learned how to write elementary rate laws. So I hope you learned something, guys, and that's all. Thank you.